Have you ever built an AI system that worked perfectly in your demo but completely fell apart the moment you try to add whoops or tool selection? You start with a small list of LM calls, then suddenly you're drowning in nested if-else statements and manual state management. Suddenly, your prototype becomes an unmaintainable nightmare. Hey everyone, my name is Venelin, and in this video I'm going to show you how to get started with LangGraph. You're going to learn how to build AI system just like factory assembly lines instead of writing a spaghetti code. We built the same intelligent support ticket system twice, first as a workflow, then as an AI agent, so you can understand exactly when to use each approach. The complete text tutorial along with the Jupyter notebook that I'm going to show you in this video is available for free in the ML Expert Academy. Here you can find this completely free tutorial along with the complete ML Expert Pro subscription academy. So if you want to become a better AI engineer, go and subscribe to ML Expert Pro. Thank you. The LangGraph library is built on top of LangChain and implemented by the same team. This library has more of a focus towards building workflow and AI agents, so it allows you to build those graphs that we're going to be using in order to run complete agentic workflows and AI agents and deploy them in production. The use case that we're going to be using here is of an intelligent support ticket triage. In this case, we're going to be working with a company that is receiving a support ticket and it needs to do a lot of steps in order to process this support ticket. We're going to be doing classification, retrieving personal or private knowledge base information, draft responses, reviewing and revising this response. In this case, a AI agentic workflow will work great. Also, we're going to see how we can implement this into a complete AI agent. The first thing that you might need to do in such a situation is to start with a simple if and else statement, such as the one that I'm showing you right here. And don't get me wrong, if you just have, like, say, 2 to 3 nodes within your workflow or LM calls, you don't need a library such as LangGraph. I would prefer to stay with a from scratch approach. So in this case, we are going to be skipping this into a further, let's say, 5 or 6 steps. So when those steps are getting larger and larger in their number, I would prefer to switch with a bit more structured approach. And in this case, LangGraph is one of those approaches that you can use. So instead of thinking with if and else statement, LangGraph gives you building blocks to design AI systems. And in this case, the library itself allows you to get a state. This is very similar to what you get within the states within applications or libraries such as React. So you're going to be building your own state here, and this is going to be essentially the system's memory. Then you're going to be allowed to create your own graph that is going to be followed during the execution of your application. In this case, the nodes are going to be Python functions that do one job. In this case, we're going to be having classify ticket, draft response, evaluate draft as nodes. And then we'll have edges that connect the nodes, and this will specify the path of execution between the nodes and what your workflow or AI agent is going to do. All of this is provided by LangGraph, and it allows you to have some nice visualizations and a debuggable approach that you can use in order to build your AI applications. Then the question about whether you should use workflows or agents come in, and the difference between the two. What I would advise everybody is to start with a workflow. Why? Because within a workflow, you are allowed as a developer to specify and control each step of the process. You have a fixed and predictable path, and of course, you can more easily debug and further improve this path. So it is a very reliable approach, and I'm going to show you how you can apply this and implement this within the Jupyter Notebook. On the other hand, we have the AI agents, which are pretty much all of the AI rage at the moment. But in production, AI agents are really hard to implement since you allow the LLMs to make the decisions. And of course, even though we have very powerful LLMs and hybrid multimodal models, sometimes if you have a very specific workflow that needs to be done in a specific order, AI agents are unable to follow concretely the steps that you need to do. So for the agents, we're going to be using the Reason Act Observe loop, which is proposed in a paper by Google. Then we're going to be building our own set of tools that our agent is going to be using. And I'm going to show you how you can essentially convert your workflow into a set of instructions that you're going to be passing to your AI agent. When building a real-world AI agentic or workflow application, you still need to have human oversight. Even though LLMs are getting smarter and smarter every day, human in the loop is still a very important technique that allows you to double check or even guide the AI systems so you can get even better responses and results from your agentic workflows or AI agents. I'm in my local cursor instance and you can see the imports that we're going to be using. Most of those are actually going to come from LangChain, but from LangGraph, we're going to be using some of the graph end and state graph itself. Also, we're going to be using a pre-built node for our graph called toNode that I'm going to show you when we are going to be building our AI agent. The LLM model that I'm going to be using is Qwen3, the 8 billion parameter variant, and this is going to be used through the Ollama instance that is going to be also running locally on my machine. Our intelligent support system workflow is going to start by defining a state. In this case, I'm going to be using a simple data class to create our state. And here you can see that we have a ticket text classification for it, retrieved documents, drafted a response, some feedback after the evaluation, and the number of revisions that our draft is going to be getting. And the next part here is to generate or write all of the nodes that we are going to be needing for our workflow. The first one is going to be the classification of the ticket. Since we're going to be using the Qwen3 model for all of the nodes, I'm going to be using that to classify the response and the ticket that is going to be passed right here. This is just calling a LangChain LLM, and I'm going to be returning this classification as text right here. So the next one is going to be retrieving information from the knowledge base. Since we have this customer support system, I have stubbed 3 pieces of sentences that we're going to be using here as an internal knowledge base for the company itself. And I'm going to be using in-memory vector store to simplify the implementation of a very, very basic rack system. So based on the ticket text, this rack is going to be returning some or pretty much all of the retrieved knowledge base. And after that, we're going to be asking the model to write a draft response for the ticket text using the context that we have just found. And you can see here that we're going to be using the state. And from there, we're going to be invoking the LM and returning the response. This response and pretty much all of the previous ones are going to be added to our state right here. And even though we are returning dicts, this is going to be automatically converted into the model that we have created here using our data class. So after the response is complete, we're going to be using the evaluation prompt, and this is going to be asking, does this draft fully address the ticket? If not, provide feedback, respond with pass or fail, and then the feedback. So again, we're going to be passing this to the LM, but this time around, we're going to be having this evaluation feedback, since this is going to be the result from the LM call. and then I'm going to be incrementing the revision count right here. So after this is done, we are going to be asking our additional node to create a revision from this draft. So this is going to be passing now also the evaluation feedback, and now the new draft response is going to be added to our state right here. The final node that we're going to be having is this should revise node, which is going to be a decision node. And in here, if the feedback is fail, we're going to be continuing to the revise response node. Otherwise, we're going to be just ending the execution of our graph. And in order to create our graph using our nodes, we're going to be using the state graph that is provided by LangGraph. The first thing that we're going to do here is to essentially add all of the nodes that we have just defined. And then we're going to be connecting those. For example, we are going to be connecting the classify node to the retrieve node, then the retrieve node to the draft node, draft to evaluate, and then a revise again to evaluate in order to create this revision to evaluation node. And then we are going to be adding the conditional edge using the should revise function. And this is going to tell us, okay, if we need to revise the draft, we're going to be again going to the revise node right here. Otherwise, we're going to be ending the execution. And important thing here is that we're going to be adding an entry point. Pretty much all of the support tickets are going to be starting with the classify node, and then I'm going to be compiling this graph. So this is going to return a compiled state graph instance. As you can see, one amazing thing about LangGraph is that you can use the graph as a mermaid diagram and display this into a PNG, as you can see right here. So in effect, you are going to get your workflow represented with this diagram, and you would probably a bit better understand what is happening under the hood. Now that we are starting here, passing the classify, retrieve, draft, evaluate, and then within the evaluate, we can go to the end, but first we are going to be going to the revise. And after n cycle right here, we're going to be ending up at the end. To run the workflow, we're going to be creating an initial state, which is going to contain the ticket text, my login is broken, please help. And then I'm going to be calling the invoke with the initial state on the application that we have just created. So on my machine, this took roughly a minute to complete since my machine is very low spec. But you can see here that we're getting pretty much all of the available state variables. So for example, since this is a reasoning model, when I ask about the classification of this ticket, the model says that the support ticket should be classified under technical issue. This is very good compared to the what we have given to the within the prompt. Only one revision was applied to this draft that is right here. And after the reasoning, you can see that the model has produced this response. Your login issue can be resolved by resetting your password using the forgot password link. Note that this information was actually added within the knowledge base. You can continue to experience issues. If you continue to experience issues, please provide additional details so we can assist further. Okay, so this is the response, and it is very nicely grounded within the knowledge base that we had. To convert our workflow into an AI agent, we are going to be converting pretty much every node that we have within our graph into tools. And then we're going to be applying the React loop or reason act observe pattern via the system prompt that I'm going to be passing to the agent. The tools themselves are going to be just custom tools built using LangChain. So I'm going to be replacing and reusing actually the prompts that we have with just LM calls here, retrieving of the knowledge with the retriever, and then drafting the response. Note that now we are not passing in any state, but we are passing just the ticket text right here. And all of those tools are going to be called by our LLM. And here I'm creating the list of the available tools. This is the system prompt that roughly implements the React pattern. First, classify the ticket to understand its category. If the ticket is technical issue, retrieve relevant knowledge. Finally, draft a response to the user. You must use the provided tools to perform these actions in sequence. Respond only with the final draft response once all steps are complete. Note that I'm here skipping the part of improving the draft, so you can add this on your own if you want to. And here you can see that I'm using the chat prompt template in order to pass in the system prompt and then the messages that we're going to be building now within the state of our AI agent. The first thing that I'm going to do here is to bind the list of tools that we have, and then I'm going to be passing in the agent prompt to the LLM using the LCL language from LangChain. The state here is going to be much simpler. We're going to be having just the list of messages, and then we're going to be adding this add messages function, which is a reducer provided by the LangGraph library. What this is going to do is to add the messages within the response. So for example, if we return from our node right here the dict with messages and a list of the response, this is going to be added to the messages list for the state. So in essence, our state is going to be just a list of the messages within the conversation. And here is how you can define your agent node. Again, passing just the state, then adding the agent invoke with the state itself. And for the tool node, we're going to be using the integrated tool node with the provided list of tools. This is again provided by LangGraph. And here we also have this should continue node, determines whether to continue the loop by calling tools or end the process. So in this case, if we have a tool call, we're going to be executing this tool call. Otherwise, we're going to be just finishing the response. This time the graph is much simpler. We are going to be adding just two nodes, one for the agent and one for the tools. The entry point is going to be the agent to node, and then we're going to be adding just a single conditional edge, which decides whether or not we should execute a tool or just end the execution. And we're going to be adding again an edge from the tools to the agent. Again, you need to compile this graph. And this is the image or the diagram of this particular execution. As you can see, much simpler compared to the previous one, but also you're not controlling the flow of the execution and which tools are going to be called when. To run the agent itself, you're going to be creating your initial agent state with a list of messages. In this case, my message is going to be exactly the same. And I'm going to be calling agent_app.stream in order to get the responses or the messages from the execution as they're coming in. And this is the output from this very long execution. Let me go through this with you. First, we start with the agent, and then the agent is doing some reasoning or thinking. And the result of that is that it wants to call the classify ticket to with the ticket text, my login is broken, please help. Then we're getting a tool response, and then here the agent is saying the ticket my login is broken, please help should be classified under technical issue. So all of this is running within the internal LangGraph loop. Then the model continues with call to the retrieve knowledge with again the same ticket help, and we're getting the response, which is essentially the list from our knowledge base. Then the model is calling the draft response. Note that here it is passing in the context for the two or three responses along with the ticket text itself. And then the model is doing a lot of reasoning. And then after that, you are going to get the ticket response. Hello, we're sorry to hear about your login issue. Please try resetting your password via the forgot password link. So the model is now working on this particular part using the grounded information from our internal knowledge base. And pretty much this is the final response again that we're getting within this agent. So this is it for this video. We've seen how you can build agentic workflows or AI agents with LangGraph. When you decide between the two approaches, you need to think who wants to control the workflow, you as the developer or the LLM. And in most cases, you should definitely start with a workflow since you're going to be able to much more easily debug and understand what is happening under the hood. Most companies or businesses have processes that are essentially workflows or discrete steps that you need to implement via LLMs or other tools. And after this is done, you will be able to get this very nicely improved and running workflows. So start with a workflow, try to implement everything within that workflow. If that doesn't work, you can also add sub agents within your workflows. This is a bit more advanced, but we're going to be covering this into the next couple of tutorials. And then you can also flip or switch to AI agents if you just want the LLM to think of everything. But keep in mind that you should probably do a lot of debugging, a lot of use case testing, and a lot of prompting to have AI models, such as even the smartest currently ones, running as good AI agents. Thank you for watching, guys. Please like, share, and subscribe. If you want to get access to the complete text tutorial and the Jupyter notebook, this is free and it is available within the link down into the description of this video. And if you're serious in becoming an AI engineer, go and subscribe to ML Expert Pro, where you can find a complete AI engineering academy. Thank you, and I'll see you in the next one. Bye.